So today we're going to talk about how to find area of a four-sided figure, a rectangle or a square. Pretty straightforward. We have a number of rows and columns and we want to see how many square units we have. You're probably familiar with this little formula right here. Area equals length times width. First, second, or third graders do these kind of area problems where you have area equals, you have a length of 3. I'm sorry, we should say the length is 4, the longer side, and a width of 3. So we're going to have 3 times 4, and we can clearly count if we wanted to see that we have an area of 12 units squared, or square units. This is a useful formula because if you have 1,000 miles or hundreds of meters, you don't want to have to count every single square unit. You can use this cool little formula to find out how much space you have. Coming over here, it's a little more complicated because we have these fractions of a unit. Not everything always measures out to be a whole number or an integer number, but we can use this same formula here. We're going to say area equals, we have a length of 4 1/2, a width of 2. We're simply going to multiply these things together. So there's a couple ways to think about this. We can say 2 times 4 plus 1/2. 2 times 4 is 8. 2 times 1/2 is 1. So we see that we're going to have 9 units. And instead of writing squared, I'm going to use the little exponent of 2 right here. And we can count our 8 units. And we have 2 more half units, which gives us our 9 square units. Real quickly though, to work with this fraction algorithm, another way we can think about this, we can make this an improper fraction. If we can put 4 in the halves, 2 times 4 is 8, plus 1, this is 9 halves, times 2 over 1, which gives us 18 over 2, also equivalent to 9 units. When we work with real world spaces, rarely do we always get an exact whole number like this. Here's an example of something we might see. In this case, area equals 4 times 2 1/3. If we utilize the distributive property the same way we did here for the second one, we would say 4 times 2 plus 1/3. That is 8 plus 4/3. 4/3 is the same as 1 1/3. 8 plus 1 1/3 equals 9 1/3 square units. Verify this visually. 1, 2, 3, 4, 5, 6, 7, 8. This is a third of a unit here. 3 of them would make 1. We have 1/3 left. I want to go ahead and show you one more algorithm. Pause if you want to take note of this distribution here, distributive property. We have 4 rows of 2 1/3. If we make this 2 1/3 into an improper fraction, 3 times 2 is 6, plus 1 is 7. 7 over 3 multiplied by 4 over 1 gives us 28 over 3. We ask how many times does 3 go into 28? Well, 9 times. 9 times 3 is 27. We'll have 9 1/3 units squared. So we just found the area for all of these figures. Quickly to review, we're going to talk about the perimeter. So area gives us the square units on the inside of a figure. Sometimes they're fractions, but we can still compile them together. Perimeter gives us the one-dimensional space on the outside. So if you want to lay carpet on a space, you look at area, what we just discussed a couple minutes ago. If you want to build a fence around something, you want the perimeter. So you can easily see here that we have 3 plus 4 plus 3 plus 4. This is kind of like combining like terms here, even though we don't have variables. We can say this is 2 3s plus 2 4s. And this is how we derive our perimeter formula that saves us time, especially when we have big numbers. Perimeter equals 2 times length plus 2 times the width. In this case, our length of 4, 2 times that is 8. 4 and 4 is 8. 2 times a 3 is 6. We can add those together to say that we have 14 units. Not square units this time, just regular one-dimensional units going around the outside of our figure. It's going to be a little more tricky over here because we have fractions, but we can definitely handle this. We're going to say Perimeter equals 2 times our length, which is 4 1/2, plus 2 times our width, which is 2. This is easy to see as 4. Think of this as $4.50, $4.50. If you have $4.50 2 times, you're going to have $9. Similar thing we did with the distributive property before. 2 times 4 plus 1/2. 2 times 4 is 8. 2 times 1/2 is 1. 8 plus 1 is 9. So our perimeter here is going to be 13 normal one-dimensional units. We can see 4 1/2 here, plus 2 makes 6 1/2, plus 4 1/2 more makes 11, plus 2 more gives us 13. Last but not least, we have perimeter for this last figure is 2 times our length of 4, plus 2 times 2 1/3. Okay, 2 times 4 is 8, plus, I'll do a little scratch work under here, 2 times 2 plus 1/3. 2 times 2 is 4. 2 plus 1/3 is, 2 times 1/3, 2/3 here. So 2 times 2 1/3 is going to be 4 2/3. So 2 plus 2, you see the 4 units here. 1/3 plus another third makes 2/3. And then you have the 8 units on the side here. Clearly I made a little mistake here. This should be 4 2/3, not 4 1/3. 8 plus 4 1/3 is going to give us 12 1/3 units. Here we should have 12 2/3 units, not 12 1/3 units. Not square units, just regular one-dimensional units.